Let's try to determine which one is a bigger number. Is 3 to the power pi is bigger or pi cube is bigger? Let's use calculator. 3 to the power pi, if we use calculator, that's equal to 31.544, and pi cube equal to 31.006, both approximately. But we can conclude that 3 to the power pi is bigger than pi cube. So we are done. Not exactly. What if the question asks you, don't use calculator? So if we are not allowed to use calculator, maybe we can use calculus. Okay, let's use calculus then. So we know that 3 to the power pi is bigger than pi cube. So let's write it. 3 to the power pi is bigger than pi cube. That is true if, see, pi is exponent, right? Power or exponent. So that reminds us about exponential function. We know that e to the power log of x is simply equal to x. Exponential and log are inverse to each other. So e to the power log of x is simply equal to x provided x is greater than 0. So let's do same thing here. So let us replace 3 to the power pi by e to the power log of 3 to the power pi, of course log with base e. Let us replace pi cube by e to the power log of pi cube. They are basically same numbers. So this inequality is true if this is true. Now log has a property that powers can be taken out of the logarithm. Log has a property that powers can be taken out of the logarithm. So this is true if e to the power pi times log of 3 is greater than e to the power 3 times log of pi. Now you see that you got the same base. So we have exponential inequality. So if we get the same base, our work is easier. So we are in the track. Now further we observe that 2 to the power 10 is definitely greater than 2 to the power 8. 2 to the power 8 is greater than 2 to the power 5. 2 to the power 5 is greater than 2 to the power 1. What we say is that if I choose x greater than y, if x greater than y, then 2 to the power x is greater than 2 to the power y. We know this, right? This is true even for exponential function. So if x is greater than y, then e to the power x is greater than e to the power y. We call such function monotonically increasing function. As we said earlier, we would like to apply calculus. So let's apply calculus to show that fx equal to e to the power x is a strictly monotonically increasing function. In other words, if x is greater than y, then e to the power x is bigger than e to the power y. So proof of claim. As we said earlier, we will apply calculus. Fx equal to e to the power x, then f dash x, derivative of fx, is d dx of e to the power x, and that's simply equal to e to the power x, which is greater than 0. And by theory of calculus, if derivative of function is greater than 0, we know that fx is strictly monotonically increasing function. Therefore, fx equal to e to the power x is strictly monotonically increasing function. What we mean by that is that if we take x bigger, fx will also be bigger. Now, as we have shown that fx equal to e to the power x is strictly monotonically increasing, if I can show that this number is bigger, then e to the power that will also be bigger than this. So we just need to show that pi times log 3 is greater than 3 times log pi. So it is sufficient to show that pi times log 3 is greater than 3 times log pi. That is true if pi times log 3 minus 3 times log pi is greater than 0. Well, that's also not easy. So let us define another function gx. Let gx equal to, let's replace pi by x. X log 3 minus 3 log pi. Sorry, x. We are replacing pi by x. We are replacing pi by x log with base e. Then what can you say about derivative? We want to show g to be monotonically increasing, but when we say logarithm of a number, we mean the number to be greater than 0. So x greater than 0. Derivative of g, derivative of x is just 1. Log of 3 with base e as it is, minus 3 times derivative of log x with respect to x is 1 by x. Now we know that g to be monotonically increasing if g dash x is greater than 0. We just use the same thing. If f dash x is greater than 0, then f is monotonically increasing. So we will apply same thing once again, but for a different function. Now when is it that g dash x is greater than 0? But g dash x is greater than 0 if log of 3 with base e minus 3 by x is greater than 0. Which is true if log of 3 with base e is greater than 3 by x. Now as we have assumed x is greater than 0, we can multiply this by x. We can cross multiply. X is greater than, which is true if x is greater than 3 by log of 3 with base e. Of course, log of 3 with base e is also greater than 0. These are positive quantity. We'll see why. Now, what can you say about this number? We know that, let's define another function, hx, to be log x. Then what can you say about h dash x, comma x greater than 0? Log is defined only for positive quantity. H dash x is derivative log x is 1 by x, which is greater than 0. Therefore, h is also monotonically increasing. So h of 3 is greater than h of e. H of 3 is greater than h of e. If you take higher number, 3 is bigger than e. So h of 3 is greater than. So log 3 is greater than log of e with base e, which is 1. So this quantity in denominator is greater than 1. So this quantity, everything is less than 3. Less than 3. We know g to be monotonically increasing if x is greater than 3 by log of 3 and this quantity is less than 3. So we can definitely say that g is monotonically increasing. So we find that g is strictly monotonically increasing for x greater than or equal to 3. Now look at the function g that was obtained by taking x equal to, replacing pi by x. So now let's replace x by pi and 3. If g is strictly monotonically increasing, we know that g of pi must be greater than g of 3. If I take bigger number, value of the function will also be bigger. Now how much is g of pi? G of pi is pi times log 3, pi times log 3 minus 3 times log pi. That is greater than g of 3. G of 3 is 3 times log 3 minus 3 times log 3. 3 times log 3 minus 3 times log 3. So g of pi we have written, g of 3 we have written, but this much gets cancelled in 0. So I can say that pi times log 3 minus 3 times log pi is greater than 0. Okay, we can take this number to the other side to say that pi times log 3 is greater than 3 times log pi, and we are done. If you are not convinced, then we observe that if this is true, from there it follows that as e to the power x is greater than e to the power y whenever x is greater than y. If x is greater than y, comma, e to the power x is greater than e to the power y. So just apply that result. And so pi times log 3 is greater than 3 times log pi. So e to the power pi times log 3 is greater than e to the power 3 times log pi. Of course, our work is done by this step. We are able to conclude with calculus that 3 to the power pi is greater than pi to the power 3. But just for 1 or 2 extra work, again, powers can be taken out of logarithm. So this can be written as e to the power log of 3 to the power pi is greater than e to the power log of pi cube. But we know that e to the power log of x is simply equal to x. So that gives us 3 to the power pi is bigger than pi cube. And once again we are done.